All right, thanks for attending. Just let's give it a little bit more time for some of the folks to show up. Today we have a Knative team, so I don't see them on the call yet. So just give it a little bit of time for them to show up. It looks like some of the folks, good morning, everyone. It looks like some of the folks are having trouble with the Zoom link. Glad you were able to figure it out.
So there's a Zoom link in the meeting, which is wrong and points to a meeting named CNCF TAG-Runtime. And then there's a meeting ID further down that's correct if you use that to connect.
Got it. Yeah. Awesome. Yeah, I'll talk to Amy about it for the CNCF, and we can get that fixed. Yeah, thank you for attending, and we're excited to hear about the Knative project. I'm going to post a link on the chat, and please add yourself as an attendee. And yeah, and I'll just hand it back to you. I think Evan or the Knative team. So.
We've got a bunch of us here, but I'm willing to start the introductions. I don't know how much people have already heard about Knative, so I'm just going to start at the beginning and channel this towards guesses at what TAG-Runtime is aimed at, and you can correct me if I go wrong along the way.
Sure, sounds good.
So Knative is a project that started about 4 years ago or so to build a serverless environment that could fill the needs that like AWS Lambda fills in the AWS ecosystem in the open source using Kubernetes design principles. And so what that means more concretely and fundamentally is that we have a component called serving, which takes a container and runs enough copies of it that for every request, there's a container that can answer it. You can control, unlike Lambda, you can control the concurrency. So it's not always a one-to-one. So in AWS Lambda, if you get 50 requests concurrently, you have 50 instances running. On Knative, you could have 50 instances running if that's how your app is programmed, but you could also say, I can handle 10 requests at a time and have only 5 instances. And it scales down to 0. It's based on the observation that most applications, or maybe not most applications, but there's a lot of applications that look roughly like 12-factor apps, including all of the function stuff. And so why don't we build a platform that works for all of those, not just for new applications that were written specifically for that endpoint. The second component is eventing, which attempts to solve the same types of problems that AWS's Event Bridge solves of, hey, there's a lot of people who are producing events and a lot of people who are interested in events, and it can be hard to glue those two together. And so let's provide some primitives that give you the buffering and the routing capabilities that you need to do that glue. And that's built on HTTP delivery of cloud events posts, basically, and delaying your response to the post until you've either handled the event and maybe have a reply to send back, or until you've stored it durably so that you've taken responsibility for that. And then you can say, okay, you know, upstream, you don't need this anymore. I've got it from here on. And I'm happy to go into more details on those. Any questions before I go further?
Are you presenting by chance?
I am not presenting at the moment.
Okay, just wanted to make sure.
I have some stuff that I could present later, but I figured I'd start with the high-level description, and if people had specific questions right up front, I'd address them. Otherwise, I can dive into some overviews of how things work.
No questions, I think.
Okay.
Yeah, thank you.
I'm going to use Roland's deck. He made it look all pretty and polished, and I just have
That's really nice.
Google Docs in its raw form. So I'm going to share screen in just a moment.
You know, treadmill.
Yeah.
Yeah.
Okay. So hopefully that everyone can see this window. Roland is another member of the Knative Technical Oversight Committee. And these are some slides that I guess he uses for pitching both OpenShift and Knative in general. But the observation here, I actually like Kelsey's Hightower's callback even further, that serverless is inetd, 40 years later, 50 years later. Rather than running a server all the time and needing to manage all of those connections, you offload that to some component, and then you just focus on, writing your application to a much more simple interface, CGI bin or inetd, instead of having to deal with TCP sockets and listen and all of that. Your program gets started, it gets fed standard in of the request, and then it gets to respond back with standard out. And so that's a pretty simple contract. And so two things that get conflated and I feel like really need to be teased apart is serverless and function as a service. And I'm glad he's got a slide on this, but basically serverless is, hey, I don't think about my application in units of servers. I think about it in terms of application units, whatever those might be. So a half and half example is Kafka, where you're really interested in partitions rather than like Kafka nodes, except that there are limits on your partitions based on the number of nodes you have and some other infrastructure things. So it's not quite as serverless as you'd want it to be as a developer. Something like AWS Kinesis steers you further in the not serverless direction because you pay per shard or partition. And so when you say, oh, and it's hard to change that number. If it's really easy to change that number, then, that's not a big deal. That's mostly serverless. But if it's hard and you kind of feel the servers underneath when you're like, oh, I want 6 partitions instead of 3, now I have to do a bunch of application work to manage that change. You've moved away from a serverless model. Whereas if it's basically, this one goes to 11, then you're kind of more in a serverless model. And we've been doing this for many years in different forms. Function as a service is a newer concept. And I definitely credit AWS Lambda for this, which is instead of having a model where you run a whole server, you write one function worth of business logic, and then someone else comes in and wraps the server around it to make a full process. So you don't even write a main, which is kind of weird to people who've been writing Unix programs for a long time, that, oh, there's no main. Even in Windows programs, like somewhere buried down there, there's a main. but you mostly, like if you've been doing UI stuff, you mostly write in terms of event loops. And similarly, if you're like JavaScript in the browser, you don't get a main, you just get a bunch of event loops that you hook into. And because you've only got one function, you tend to not to build a full application in a single deployment. You build a piece of it like a single API call. We talked about what that was already. We talked about serving and eventing a little bit. And so one thing is that we release every 6 weeks. So our version numbers go up a little faster than Kubernetes do, but we recently turned over the clock from 0 point something to 1 point something because we felt like everything that was our baseline of stuff to accomplish was done, including things like documentation. And here's a bunch of different places to try it. And so you can see that we didn't just tackle scale to 0, but we tackled a couple related things at the same time. Rollouts, revisions and rollbacks, and traffic splitting are kind of tied up in that same space. We also do a bunch of things that restrict you from the full Kubernetes. You can do everything model. So we say, only one port. We say your persistent volumes are pretty limited because those tend to produce scalability issues and sharing problems. So our default is don't do that. We have some feature flags that people have introduced where you can go and turn on, hey, I know this is a bad idea, but I really need it for my application. But and then the other difference is that traditional Kubernetes deployments, when you go to roll them out, you work in terms of sort of server units to say, oh, we're doing a rolling restart. I'm going to restart one server unit, then I'm going to restart another server unit, then I'm going to restart another server unit. In Knative instead, we lean heavily on the autoscaler and we have you shift traffic. So you say, hey, 10% of traffic is going to the new revision. However many instances that needs, it's 10% of traffic. And so if you're an app that only is served by 3 servers, when you move that 10% over, maybe you're served by 4 for a little while. If you're an application that has a huge amount of load and you're 500 servers, well, then you probably spin up 50 servers, or spin up 50 pods over here and spin down 50 pods over here because the autoscaling says, hey, these aren't needed anymore. But you think about it in terms of how much traffic you want going where, rather than thinking about it in terms of like units and progressing and things like that.
I have a question. Sounds like you use the HPA, but do you also use the vertical pod autoscaler or just?
We actually have our own autoscaler that's concurrency based.
I got it.
So the number of requests in flight is what we key off of. And it runs in a somewhat tighter loop than the HPA does typically. You can sub in the HPA if you want to. You can opt out of our concurrency-based autoscaling, but we found that concurrency-based is a pretty natural approach for a lot of these applications.
Got it. Makes sense. All right, thanks.
So this is our object model. The way that configuration works is every time you make a change, it stamps out a new revision, much like deployments stamp out replica sets, except that they're more explicitly exposed, and so it's easier to talk about. Go back to this one or send 10% to that one, whereas the replica sets under the covers are very much under the covers of deployment. Oops. And also, because we've constrained the model a lot, we can simplify. I've pointed out to Roland that this is actually not accurate because you don't need the metadata labels an app label here. So your spec can just look like service, name, spec template, spec containers, image, and we'll actually assume a container port of 8080 if you don't specify. So, in 8 lines or so of YAML, you could actually specify a Knative service that will run an image that listens on port 8080 for HTTP traffic. You also get inbound request balancing. So like an ingress in a service, you get auto scaling. and you can get automatic TLS. And we're just going to skip over the demo. We've got a technical oversight committee meeting in about 15 minutes. So that's why we're only going to fill half the time.
Yeah, no worries.
And so I don't know how much people know about cloud events, but this is a CNCF project that basically aims to produce like an HTTP of message processing. So what often happens today is, you have your RabbitMQs and your Kafkas and so forth, and they all have slightly different formats. And when you get a message off of, say RabbitMQ or Kinesis or something like that, and the next application that needs it is Kafka, you have to write some pretty stupid code that's basically like copy things from here in this format to here in this format, and you have to make some choices. And you should just be able to say move message from here to here. But because they all have slightly different metadata and data capabilities, you end up reinventing that a lot. And so Cloud Event says, hey, we're going to have some key value headers with simple string names, for the keys and a limited set of data types for the values. And then we're going to have a payload. And the payload is effectively bytes with maybe a MIME type associated with it. So it's not as rich as you might get in Kafka or something like that, but it's translatable through a lot of different layers. And we particularly use the HTTP layer because what if there was something that would scale up and give you the capacity you needed when you got an HTTP post? Wouldn't that be convenient? And so we've been building out an ecosystem of adapters, which we call event sources. So you can get events from a variety of AWS services. You can get events from things like ZenHub or Slack. And oftentimes this is basically you create a Kubernetes object, it spins up a pod and does some control magic to either register for a webhook or pull an endpoint. And then every time something happens there, it converts it to a cloud event and should have a documented schema for what those events look like. And this feels like a rich place for third-party integration. Right now, a company called Trigger Mesh, which is a startup, has done a lot of this work for both the public clouds and for some of the other main services like Service Desk. But this feels like it's an independently useful thing. The one drawback for some of these is that they may not have a lot of buffering available.
One question for these events. So I guess you need an extra processing there because you said that you have a Kubernetes pod, and so there's a conversion basically, and then so you can have multiple of those, right? So to support the multiple event types or source event types, and then convert those to cloud events, right?
So for each type of thing that you're converting from, there's a different CRD, a different event source, so that they can have a rich schema as opposed to just like, you've seen the Kubernetes objects that are either a flat like set of key value pairs or like blob of JSON here, basically. Rather than having either of those, we actually have a loose contract that says, hey, a source should have a particular field called sync that either references an object that has a URL or references a Kubernetes service. And then it has some other parameters, and go look in their documentation for what those parameters are. Or use kubectl explain.
Got it. So, but do you
so
have only
there's a lot of different sources. Go ahead.
Yeah. So you only have one pod to translate all the different sources then?
No.
And then okay.
Each source is effectively its own operator, if you like to talk about the operator pattern. Otherwise, it's its own controller, and it can implement whatever strategy makes sense. Maybe it starts a single pod for the whole cluster and does things multi-tenant. Maybe it starts a pod per namespace because that feels safest and most isolated. And customers can choose what model they want and collect these. We have a big long catalog of here's ones you can install in your cluster.
Got it. Sounds good. Okay.
So yeah, you can hook a source directly up to something like a Knative service and it'll post events. And if the Knative service is down for some reason or produces an error, probably what happens is, poof, your event is gone. You'll never see it again. Maybe the source implements some retry. Maybe it's got some queuing capabilities, but a lot of them, it's hard to do that type of thing. And so the real intent is to stick something like a channel, or we have another construct called a broker in there. And those provide durable queuing backed by something like Kafka or GCP PubSub, RabbitMQ. We have a in-tree one called in memory, which is durable as long as the pod runs. And then if your pod gets rescheduled, your durability guarantees are gone. And so this allows you to build, different traditional messaging architecture patterns. We also have a system called Broker, which is where we tend to steer new users towards because it gives you a little bit more flexibility and less need to plan things up front. So all your sources dump events into a broker, and then brokers have triggers that include a filter expression that says, oh, hey, cloud events like X should be sent to this destination. And it's up to the broker implementation to optimize that. And so you can imagine under the covers, if you had this topology, a smart solver could say, hey, I'm actually going to create two underlying channels, one for orange and one for, greenish, bluish, turquoise. And when something comes in, I will pre-sort it into the right bucket. You can also imagine one that says, hey, it's, these channels are expensive to make. I'm just going to make one channel. And then it's really easy to throw things out with this particular implementation. So I'll just do a, read it and throw things out at the trigger end. Both implementations are valid as long as it matches this contract. And yeah. And then this is more about the ecosystem. So CamelK has adapted many of its sources and syncs to be Knative compatible, so that you can, take a CamelK binding and convert it into a Knative source. And then the last part that's probably somewhat interesting here is this is an effort that we're still iterating on, but it's a goal to actually produce a full function experience for Knative. And so that involves actually building a set of build packs that will take some source code and transform it into a container that meets this is an HTTP service, answering cloud events type of model. And so you write your function, and then the build pack goes and injects like maybe a main and an HTTP server. So if you're Java, it does its Java thing, it adds the dependencies and, a main and maybe Tomcat or Netty or something like that. But this gives you that experience of, hey, I just wrote a function. I didn't even have to think about all of that nasty, like, how does HTTP work? And then I just thought about my business logic and, oh, look, now it's running on Kubernetes scalably and I don't have to think about it. And so this currently runs mostly client side. We're looking at how do we make it possible to do remote builds because let me start that over. We're looking at how to do remote builds because the pack tools from build packs do require Docker to execute locally, and not all developers have the ability to run Docker locally. So it looks like, okay, let's pack up the source, make it available and run it in the cluster using something like TikTok. And so, yes, this is under active development, both the interface of how you represent on disk one of these functions, as well as, the functionality of actually getting it into the cluster. But this is optional and it builds as a layer on top of Knative. So if you don't want to write functions, if you want to run WordPress, knock yourself out. I use that as an example because I have a blog that's running on Knative on a couple of repurposed thin clients, this WordPress. So, and that is pretty much it. And now you can tweet to Roland if you need to. Hello, Roland.
Awesome.
Hello. Hi. Sorry for being late.
So that's the application side of things. We don't have time today to talk about the infrastructure side of how the data flows. It's suggested in some of these slides, but a lot to cover.
Yeah, you're willing to come back another time to talk about that? So maybe in the
Probably, yeah. I don't
Awesome.
know. I don't know exactly what tag runtime's focus and interests are. So, I'm
So-
happy to dive deep into that, or do a high level view.
Yeah, the high level overview is fine, and I think a lot of the focus is just on workloads and how to run workloads in cloud native ways. So, yeah, we're happy to have you back again. But yeah, anybody has any questions? You got 3 minutes.
Thank you.
All right. Well, oh, Eric.
Question,
I think-
Are you getting your steps in, Evan?
I am getting my steps in,
Okay, just yeah. It's pretty cool.
aiming for about 8 miles or so today. So, got to get started early.
Definitely. No, this was really cool. So I'll probably spend some time and may have some questions, following up. But I definitely want to try it out a bit.
I actually pulled up just a little bit of this is how we actually do the scale to zero magic. So if you don't have any pods running, we actually stick a component in called the activator. So your HTTP router is something like Istio or Contour or a bunch of other specific implementations that we have, because we do some sophisticated stuff that Ingress doesn't really know how to manage. But we wire this component in called activator. It holds on to the request, it sort of stalls the HTTP request, turns around to the API server and says, hey, we need a pod real quick. It actually goes through our autoscaler to do it. I elided that here. And then once the pod starts up, it will forward the request onto the queue proxy. So that's how we manage to get scale to and from zero instances, which is not something that HPA will natively do. And then, as you can see, the opposite direction, when the last pod needs to shut down because there's no more requests coming in, we wire things back to the activator.
Awesome. How many people are using Knative, or do you have a rough estimate of end users? Or
we have a list of people who've adopted it in Knative community. Is that all of them? I know the answer is no. But we don't have a good estimate for exactly how large that community is.
It would be really hard to tell because a lot of the users of Knative are also using the various commercial distributions of it. So they're using OpenShift or Google Cloud Run or Tanzu or one of the distributions
IBM Code
instead of
Engine.
downloading it directly. Yeah.
Yeah.
got it.
And it gets bundled in other projects like Kubeflow. If you're using Kubeflow, you're probably using Knative as well. That you might not even
So
know
Kubeflow's
about.
KF serving for the
Renton
inference
is
side
okay.
of things.
Yeah.
They build their ML model into a container and then they run it on Knative.
Right. Yeah.
So you may be using Knative and not realize it there.
Yeah. Sounds like a lot of people and a lot of orgs. Awesome. All right. So it's
Excellent.
time for
Yep,
you to go.
we have to
your
disappear.
meeting. But then, yeah, thank you, everyone. I think we don't have anything else on the agenda, so we'll just drop
Okay.
off here. All right. We'll see you
Yeah.
next time.
Thank you.
Bye.
Bye.